WAVs in disaster management and relief operations. In recent years, unmanned aerial vehicles, WAVs, commonly known as drones, have emerged as an innovative and promising technology for disaster management and relief operations. WAVs are equipped with various sensors, cameras, and other such equipment that can capture high-quality images and videos of affected areas, which can aid in disaster assessments and relief efforts. In this article, we'll be discussing the use of WAVs in disaster management and how they can benefit relief operations. Disaster management is defined as the process of responding to and mitigating the effects of a disaster. Unlike traditional methods used for disaster assessment, such as satellite imagery and ground-based assessments, WAVs are more cost-effective and time-efficient. WAVs can access damaged areas where manned vehicles cannot, and their use can reduce risks to human life. When it comes to disaster management, time is of the essence. The quicker relief efforts can get underway, the better the outcome for those affected. WAVs can be used to quickly deliver essential relief supplies such as food, water, medicine, and other necessaries to remote, hard-to-reach areas. This can be especially useful in the aftermath of a natural disaster, where standard transportation methods such as roads, railways, and airports may be disrupted or damaged. WAVs can also provide valuable information to disaster response teams. In the aftermath of a disaster, it can be difficult for teams to get a comprehensive overview of the damage. WAVs can be used to conduct aerial surveys of the affected area and provide real-time information to teams on the ground. This information can help in determining the extent of damage, identifying areas of immediate danger, and assessing the needs of those affected. One of the most significant benefits of using WAVs in disaster management is their ability to operate in hazardous conditions. For example, in the case of an earthquake or other natural disaster, it may be too dangerous for human rescuers to enter affected areas. WAVs can be used to search for survivors and deliver medical supplies and other necessities to those who are trapped or injured. In addition, WAVs can be used to track and monitor the movements of people who have been displaced by a disaster. Another benefit of using WAVs in disaster management is the ability to collect data that can be used for planning and preparedness purposes. Data collected by WAVs can be used to develop hazard maps, which can aid in identifying areas that are at risk of natural disasters. This information can be used to develop contingency plans, preposition supplies and equipment, and conduct training and exercises to help prepare for future disasters. WAVs can also play a crucial role in relief operations. Once the initial response to a disaster is complete, relief operations focus on rebuilding communities and restoring services such as water, electricity, and transportation. WAVs can be used to monitor the progress of these operations and identify areas that require further attention. For example, WAVs can be used to conduct aerial surveys of damaged infrastructure such as roads, bridges, and buildings. This information can be used to prioritize rebuilding efforts and allocate resources more efficiently. Furthermore, as the technology used in WAVs becomes more advanced, their capabilities also expand. For example, some WAVs are now equipped with thermal imaging cameras that can detect heat signatures, allowing them to locate survivors who may be trapped in rubble or other hard-to-reach locations. This technology can be particularly useful in the aftermath of earthquakes or building collapses. Another potential use for WAVs in disaster management is for the delivery of medical supplies or equipment. In remote or isolated areas, it can be difficult to get necessary medical supplies to those in need quickly. WAVs can be used to deliver these supplies more efficiently, potentially saving lives in emergency situations. However, there are also challenges associated with the use of WAVs in disaster management. One significant challenge is the issue of privacy. WAVs are capable of capturing high-quality images and video, which may infringe upon the privacy of those affected by the disaster. As such, it is important to establish clear guidelines and regulations on the use of WAVs to ensure that they are used in an ethical and responsible manner. Another challenge relates to the regulation of UAV use in disaster management. In many countries, there are laws and regulations in place that restrict the use of WAVs. However, in the case of disaster management, these regulations may need to be relaxed to allow for effective and efficient response efforts. It is important to strike a balance between ensuring safety and compliance with regulations and allowing for effective disaster response. Despite these challenges, the use of WAVs in disaster management and relief operations has a promising future. As the technology continues to improve and become more affordable, their use in disaster response efforts will likely become more widespread. WAVs offer a fast, efficient, and cost-effective means of assessing disaster damage, delivering essential supplies, and identifying areas requiring further attention. In this way, they help to minimize the negative impact of disasters on affected communities. As such, it is crucial to continue researching and investing in the utilization of WAVs for disaster management and relief operations. With the growing number of natural disasters being experienced globally, it is vital to adopt innovative and agile technologies that can help improve response and relief efforts. WAVs have proven time and again to be a valuable asset in disaster management, and the potential for their use extends beyond natural disasters. For instance, WAVs can also be used to respond to human-made disasters such as terrorist attacks, industrial accidents, and oil spills. In such cases, WAVs can be used to rapidly assess the situation and map the extent of the damage while also collecting critical data that can be relayed to emergency responders on the ground. Additionally, WAVs can be used to monitor critical infrastructure, such as oil pipelines,